Hello, this is Savannah DaCosta here. Just doing a little bit of a video to demonstrate some aerosol jet extraction that was used on the research paper I was recently published on. The research paper's name is, let me get it for you guys. It's a characterization of aerosol plumes for singing and playing wind instruments associated with the risk of airborne virus transmission. And on that paper, we used some fancy little graphs there that were custom made from basically extracted images. Well, we extracted out the plumes from the background image, and then we enhanced the image quality using some different methods. So I just want to show you guys, quickly how things run. There's some functions here that we're going to go in depth on, particularly like the clustering, but you can just see how it runs really quickly. And you may use this in research, and it's very actually, the methods in this clustering are very, well, the clustering, the image extraction are very versatile, that you can use them in like different projects that require image extraction, image manipulation, or enhancement. So over here, it's pretty rough. Over here, it's still rough. We just sort of crop it. And these are PIP files, by the way, this particle image velocimetry. And so, yeah, so that's why the background's fairly grainy. The light needs to bounce off of those particles to, actually see how the airflow is moving. And so we go here, we actually mask that whole background, or at least the majority of it. Then we do a little bit of enhancing and smoothing, and it's going to show afterwards. Yep. Here it is. So it's a little bit smoothed out. You can see here. So there's a lot less of this grainy stuff. Well, it's not as grainy, but we can do better. So we go forward to over here. You can see some of this stuff is removed. Some of these more excess particles, or I guess, the aerosols over here are sort of removed. And then we're going to cluster it. So we're actually going to be able to see sections of this aerosol plume and see the different velocity clusters. And yeah, then we can basically use, let's say this image here would be ready for actually using on the graph or something, or whatever purpose you need it for. As you can see, it's separated from like a lot of this other grainy stuff, and it's going on and it's clustering, and you're going to see some images pop up in like 20 seconds. Yeah, it takes some time, but it's trying to get 6 different clusters here, so it's going to be fairly detailed in its parsing of the different sections of velocity that's going on within the aerosol. And this can be used to, let's say, if you wanted just to index certain parts of the aerosol, like logically index them. If you have like the original data for the velocities, so this is just an image file, we can use a basically, as you can see here, into binary. That would give us a binary matrix that we can use to actually index out those particular sections of the velocities within the total aerosol. So get the sections that are just this, actually get their values. Sections that are just that, sections that are just this, and sections that are just this. And that's all of our velocity clusters that we've got. We got 6. The first one is just black. But this is a little bit of a sample of what we're going to be doing for our project coming this semester. When it comes to working with image files, smoothing them out, clustering, we're actually going to do like a little bit of a custom clustering function that I developed for this research project. And I'll just guide you guys through that, and also the concepts when it comes to clustering. And yeah, thanks for watching. Stop the share.